Hello, well here we are again. In this video I wanted to take a look at how we can do a basic fit together of a few parts and check that they're all working okay, because if you're like me I have to wait quite a while for things to arrive from overseas, so if they arrive faulty I want to find out as soon as I can so I can make a complaint and get a replacement item. So we'll do that for the motors and ESCs and flight controller and the video gear, and as part of that we are going to have to see how to install or upload Betaflight onto the flight controller too. I'm going to start by checking the connection between the radio transmitter and the receiver, and I have my flight controller plugged in here, but the only reason I've got this ready is because if you plug the USB into this particular flight controller you'll find that the pins on, well, everywhere that's labeled with 5 volts on there will actually have 5 volts. So some flight controllers don't do this, but this one does, which is another reason I chose this one. It's kind of convenient. So right now there's going to be ground and 5 volts on those pins. So we can just get one of these servo cable plugs and make sure we get everything the right way around. You can plug it into pretty much anywhere on there, as we saw in one of the earlier videos. And I'll plug it across the ESC outputs, and we should see that it powers up. So we've got 5 volts power to there. So that's one way you can get 5 volts power. Another way is if you've already soldered this thing on here, you can have 5 volts output there in the same kind of a plug, and to get some input you'll have to solder up the connector for the LiPo battery. So you could use your LiPo battery stepped down to 5 volts to power the receiver as well. So one way or the other you'll need 5 volts to power the receiver. To check that the radio and the receiver can connect to each other we'll need to do something called binding, and binding means that this radio and this receiver are going to talk to each other, but they're not going to talk to any other receivers. So when you turn your radio on it's not going to interfere with anyone else. And the way that we do that is on the transmitter. When we turn this on, by the way, if you have these switches in a certain way, when you turn this on it will warn you to place all switches in the up position like that and lower the throttle, and then you can get started on doing stuff. So what we see here, this FlySky01, this is the current model that I have selected. So this radio you can set up to I think 20 different models. So you could have a plane and a quadcopter and another plane and a car even, and you can switch between them, and each one of these model selections will be bound to a specific receiver. And I already have this one bound, but I'll do the binding process again to show you how it works. So basically it works by you select which model you're trying to bind, and then you turn the radio off. So let me just show you how you can switch between different models. You hold down the OK button, and that will show you this menu here, and then you press OK on System. You can select between these like that. So System Setup, and then Model Select. So press OK again, and then by going up and down here we can choose a different model, and by default the names that they are given is all just FlySky 0, 2, 3 and so on like that, but you can set your own name. Now this radio is a bit weird. The way that you choose something or you confirm your selection is by holding down the cancel button, and it makes a different pitch noise. So if I go OK on Model Select and then I just tap cancel quickly, it makes a low pitched beep, whereas if I hold it down it makes a slightly higher pitched beep. It's not a very good system really. So hopefully you can tell it's a slightly different pitch. I think it would have been much more sensible if you hold down OK to confirm something, but I don't know. That's not how it works. So anyway, you make your selection here, whichever model you're trying to bind. I'll just leave it as FlySky1. Oh, hang on a minute. Let's just also look at this model name. We go in here, we see the cursor is on the F at the moment, but if I wanted to call this Basic Quad, I could choose a B, and then an A, and then an S, and then an I, and then a C, and then I'll just give it a Q, otherwise we'll be here all day. with space there. So it's going to be called basic Q1, and then remember to hold down cancel to set that, and then cancel will go back to the previous menu here and again. So now we'll see basic quad 1 is what I've set for my model 1, so model 01 is the first model. So I've given it a name. This just helps to differentiate between them when you have lots of them set up. Anyway, so once I've selected the model that I want to bind, I turn this off, and then I hold this button over here that's labeled bind/range test. It's not going to focus by the looks of it, but it says bind there. So I hold that down, and I switch the radio on, and then I let go of that. So we've entered a different mode where it just says RX binding. So what it's doing is it's waiting for that one, or it's waiting for a receiver somewhere to turn on, also in binding mode, and then it will pair itself up with that receiver. So the way that we do this is kind of similar. We have it off to start with, and we need to make a connection between two of these pins. Now see, the top one is labeled B/VCC, so that B stands for bind, and it means that we need to connect ground, the bottom one, and the top one, which is the signal pin. And you can do that by a wire that just loops around onto itself like that. So I'm going to plug this into the last row. So it's going to be in there like that. Come on, camera. Anyway, it's in the very topmost row. And then I'll plug in my 5 volts, and we'll just see if we can see that change as I plug in the receiver. And I can plug this in anywhere because these are all just the same ground and 5 volts rails. So let me just plug it in here. And you may have just seen it said binding OK or something, just quickly showed up there, and it beeped, and now we're back to the standard menu like that. So from this point on, we don't need that bind plug anymore. We can just get rid of that. Well, keep it in case you want to bind something else. But now this radio and this receiver are paired up together so that whenever I choose this basic Q1 that I set up, it's going to talk to this receiver and nothing else. And a couple of other things we can notice now is that we have some extra display. It says internal voltage 1, transmitter voltage 1. So TXV1 is the voltage of this radio, so that's whatever voltage those batteries are currently putting out. Actually 4.8 is very low. It's about as low as it can go. It's probably going to start beeping and warning me that this is too low quite soon. Hopefully not while I'm trying to make a video. And then internal voltage is the voltage that this receiver is running at. So it's whatever this is putting out to supply the receiver, which looks like 5.09 volts in this case. And we can also see that there's a little LED on the receiver, which when it's on and it stays on means that we have a proper radio connection. If I turn this off, after a moment it will start flashing, so that means we have no connection. When I turn it back on, it should go solid. So that's another way to confirm that everything is working correctly. Now that we have that done and connected, we can actually use this to help us check the ESCs and the motors, which is the next thing that we need to check. So when you get these motors, just give them a quick spin around, and they should feel fairly smooth and quiet. They shouldn't be rattling or scratching or anything like that. This one feels pretty nice. It is normal for them to feel a little bit notchy feeling, a little bit clicky. So when I turn this, it doesn't want to turn smoothly, but it will kind of click around like a clicking dial almost. And that's because, as we saw before, it has a bunch of magnets around the outside, and those magnets want to settle into a specific position. So just to go back to this funny thing that I made, you can see that if I put this off a little bit, the magnets will pull it into a certain position, and then it will just stay wherever it wants to stay. So that is normal. Now to test the motors, you'll need the ESC connected. So this is where you're going to have to do some soldering, and that's why I did that little overview of soldering before. So you're going to have to solder up the 3 wires of each motor, and do this for each. You've got to do this 4 times. So you've got to solder up the motor on there, and then you're going to have some way of powering the ESC. In this case I have soldered up one of these connections, which is for a slightly smaller LiPo battery, which I have around here somewhere. But if you don't have a bunch of LiPo batteries sitting around, as you probably will not when you're a newbie, you'll have to get that old, get this plug that you have already, and you'll have to, whatever you've done with it, you'll have to take it off. So you'll have to do this 4 times. It's a bit of a pain in the butt, but for each ESC you'll have to solder that on to be able to connect your battery to power it up. And when you've soldered it on, make sure that you don't touch these together. So I've just used a bit of sellotape in there somehow to, pretty sure those are actually separated inside there. So you do not want to touch the positive and negative of the battery terminals together, because that will give you some sparks and lots of heat, and maybe even a bit of smoke and a bit of cursing and swearing, and you don't really want to do that. Yeah, so you'll need to power it from the battery. And the other thing that you'll need is some kind of a control, some kind of a PWM signal coming into here in order to tell it to spin or not to spin. So the way I'm going to do that is I'm just going to plug this into my receiver onto channel 3. And if you haven't changed anything else on the radio settings, channel 3 is going to be the throttle. And the reason I'm using channel 3 is because it has no spring to return it to center. Channel 1 would be roll, and I don't really want that, because if I let it go it's going to be at half throttle, which is going to make the motor spin. I just want to be able to turn it off to begin with. So I'm going to plug this ESC control into channel 3 like that, and let me just grab my battery so I can power it up. Maybe if I can hold it in front of the camera at the same time, you'll see that the motor is actually twitching a little bit while it does this. See if we can do this all at the same time. So you may have seen it moving a bit, but the way it's doing that beeping is that the motor is, the ESC is telling the motor to move a little bit in a very high pitched, high frequency, so that it makes an audible sound that we can hear. So that final duh means that everything's ready to go. So this is going to kick when it starts to move. So ideally, it's probably better to do this by, instead of just having it sitting on the desk, maybe stick it down to something like this so that it's not going to be able to jump around so much. But I'm pretty sure it shouldn't jump too much if I just do this with a little bit of throttle. Okay. It does sort of, it still jumps around. Maybe I'll just stick this onto the frame so that I don't have any problems. Hold on a minute. That's better. So now you should be able to spin the motor up, and like I think I mentioned before, it's not a good idea to spin it at full speed without any load on it like that, but if you're just doing a quick test, it should be alright. Low speed I think is safe. You're not going to damage anything like that. But anyway, this test confirms that the motor works and the ESC works, and I guess we can also now see that this PWM channel from the radio is working okay as well. And just by listening to the sound of the motor a bit, you can probably tell whether it's a healthy one or whether its bearings are already stuffed or whatever. I think this one's okay. These are not the flashiest motors, but they'll do okay. Okay, so the next thing that we'll need to check is the flight controller board itself, and when you plug it into USB you should see at least one light coming on, I think, and depending on what firmware is already on the board that you have, they may or may not have flashing lights somewhere as well. So for this next part we're going to have to get acquainted with Betaflight, and we may have to actually flash some firmware onto this board in order to talk to it in the way that we want to. So let's go over to the computer, and as I said before, this is all running in Chrome, so you're going to have to get the Chrome web browser to set this up, but that shouldn't be any problem. It runs on Windows, Linux and Mac, and we can go to the Chrome web store, so we can click here to do that, or go to that URL and search the store for Betaflight. So we want this one here, Betaflight Configurator. Click Add to Chrome, Add App, and that will just take a little time, so let me just skip ahead a bit maybe. Okay, there we go. It's added to my apps page. By the way, when you start Chrome from the beginning, if it's not showing this, you can click on this apps little icon there, and then you'll be taken to this page. So to start at Betaflight, we just click on there. On Windows 7 at least, when I plugged in my flight controller board, I saw a little notification down here saying that it was installing drivers. So I did not have to install any extra drivers myself for this particular flight controller. Now if you're using one of those more modern, fancy, expensive, well slightly more expensive ones that have a different CPU on them, you may need to find and install some other drivers manually. But for this one, it's pretty easy. You don't need to do anything. That's one of the reasons why I wanted to go with this one. And it should auto-select this selection up there as well. So I'm just going to leave it as COM4. I'm not actually sure which is which, but actually it might be worth just sort of taking a look at how we can figure this out. So if we click on here and go to My Computer Manage, don't actually have any password for that. Then you'll see this thing, and you can go to Device Manager, and ports we should see down here. Now the one that we have our flight controller connected to will be this one here, Silicon Labs CP210 something USB to UART bridge. It's actually COM6. So when I opened Betaflight, it selected COM4, which is wrong. So you may actually need to manually select this. Usually you don't, I find. But in this case I did. So this is one way you can check which COM port has which device on it. Anyway, so I'm going to go with COM6, and then I connect. And I see this for this particular flight controller. It says, warning, non-Betaflight firmware is not supported. And there's a bit more information there. But what this means is that Betaflight is not actually installed on this flight controller already, so we're going to have to install it ourselves. If I click this to continue, it just confronts us with this CLI, which is Command Line Interface. And you can still communicate with the flight controller. For example, I think dump will actually, if you type in the command dump here, you can make it print out a list of all of the settings that this board has currently made. But this is not a very nice way to interact with it, so we don't want to do this. We want to have those nice buttons and sliders and everything. So to make it so that we can do that, we need to upload Betaflight onto this flight controller. So I'm going to disconnect here, and when you're on this page where you're disconnected, there's a couple of other tabs along here. Let me just make this bigger. There we go. When you make it a little bit larger, you'll actually see some text in these tabs, or these buttons. And the bottom one is Firmware Flasher, which I'm going to select now. And you should see these lists loading up some selections. And I'm going to make a selection. Now the board that I'm using is compatible with the NAZE32. Or in this case it's just labeled NAZE. So I'm going to select this one. If you have a different flight controller board, you're going to have to figure out which of these firmware versions you need for your flight controller. Otherwise, it might just go crazy and not work at all. Could actually be a little bit dangerous if it decides to turn the props on when you're not expecting it. So you've got to make sure you get the right one. Anyway, so I'm going to choose NAZE for my flight control type, and then you can also select the version. I usually just go for the most up-to-date version, which is 3.1.7 at the current date. And I think I can just leave these ones untouched. And then currently we do not have this firmware on our computer. It's on the internet, but we can click this load firmware button and it will just changes to downloading. So it's actually downloading this firmware. And the firmware is pretty small because these flight controller computers, they don't have a whole lot of memory, so the program's not very big. I think it says on here somewhere how big it is, doesn't it? It used to. Here we go, right at the bottom it says 128 kilobytes, so it's not very big. But once it's loaded, we will see a list of info saying what has been changed in this version. It's very nice to have this, because then you can see what's new and decide whether you want to update your firmware or not. And the other thing that changes once we have downloaded the firmware is that this flash firmware button will become enabled. So now we can click this, and if everything goes okay, we'll see executing local arrays and then flashing. So we are uploading that version of Betaflight onto the flight controller. Now, in my experience with this particular flight controller board, I've never had any problems with this. I have had plenty of problems with other flight controller boards, and if you have problems at this point, you can... Where is it? Where is that help? I think it's here, is it? No? Oh, here we go. Recovery/lost communication. So there's a big list of things that you can very carefully pay attention to, and this may help you to upload the firmware. Not going to look at this in too much detail. There are plenty of forums discussing these issues that you can look up and hopefully find somebody that is having the same problem as you, that you can figure out what's going on. But for me personally, I've never had any issues with this. So anyway, now that we have uploaded the Betaflight firmware, this time when we try and connect, we should get a very, very different situation. We get a whole lot of tabs over there to choose from. One of them is actually CLI, so if we click on this, we'll see that thing that we had before. So we can still use that, but we don't really want to. So let's click on one of these other tabs, and now we have a bunch of different settings, and we'll look at this in future, but just for now, all we're trying to do is make sure that this flight controller board is working properly. And this particular flight controller board is a very simple one. It only has a gyroscope and an accelerometer, and we can see those showing up in yellow. So these first two sensor boxes are enabled, and the other ones, magnetometer, barometer, GPS, what is this one? Sonar. So we don't have any of those. That's fine. All we need, or we expect to see, is the first two, gyro and accel. And just to double check that that's working all right, we can grab hold of our board and move it around and see that the image shown on the screen is following our movements. I'm not sure why this is a rectangular box. I thought it would have been a picture of a quadcopter. Anyway, that's basically all the checks that you really need to do at this point to check that the flight controller is working okay. So once you've checked that it's alright, you may be well advised to, at this point, reinforce the connection around this USB. And you can see that I've done this. It's a little bit hard to see maybe, but around this USB plug I have placed a bit of epoxy glue, and it's sort of that smooth, shiny glass looking stuff. And the reason for this is that over time, as you plug in and unplug this USB connection, it can actually just pull right off. Some of these cheap flight controller boards are not very sturdily made, and if you pull that USB plug off, basically you're kind of screwed. It's really, really difficult to solder that back on. There are other ways that you can connect to the flight controller by using, actually this one I don't think you can very well, but yeah, you're basically screwed if that plug pulls off. So if you have some epoxy glue sitting around, you might want to just, at this point, put a little bit of it around this USB and make sure it's nice and strong. And last but not least, if you have some FPV gear, you'll probably want to check that that's working okay as well. So we're going to have to do a little bit of soldering for this one again. And what I'm going to do is plug in, where does that go, that way? I'm going to use these connections here, but we're not actually going to use these plugs, or I'm not anyway. I'm not going to use these in my final build, so I'm just going to cut those off so that I can solder these wires directly onto something. And the something in this case is going to be my power distribution board for these two wires to give me 12 volts. And again, on the transmitter, this also is going to need some power, so the black and the red of this are also going to be soldered onto my power distribution board. And I say 12 volts because that's I'm going to use a 3S LiPo to do this, but it could be just whatever LiPo battery you have. So those are going to go into my power distribution board. and then the yellow wires of each will need to be joined to each other to take the signal from the camera to the video transmitter. So those are going to, yellow is going to go to yellow like that. So let me just get that ready. Okay, so that's how that's going to look, and as you can see, I've just used my power distribution board. This has a bunch of positive and negative terminals all the way around it, which we are later going to use to connect our ESCs to, but for now they can be useful just to connect everything together. So I've got plus, minus there. So this plus and minus are going to the video transmitter, other plus and minus are going to the camera, and then the yellow wire is just going directly from the camera to the video transmitter. I've just quickly soldered it there in the middle, and of course we'll tidy this all up later. This is not the final thing, so don't worry if it's a bit of a mess. And I've actually cut off the other two wires that are on the video transmitter because these were the ground and the audio wire, and we just don't need them. Well, I'm not going to have audio on my quad, so I'm not going to use them. Now, I'm going to power this power distribution board, or well, voltage regulator, from this LiPo, but it's good to get into the habit of, as you bring these plugs together and you're about to plug them in, just sort of pause and mentally check or look over there and see what you're doing. Just sort of have a little think if everything is ready, because sometimes it's not, and no harm is ever done by pausing and just waiting for a moment. And don't know if you can tell what the problem is there, but I don't have the antenna on my video transmitter, and it may be okay for a short while like that, but it's not good to do that long term. So I'm going to put this antenna on, and then we should be ready to go. But there's still a problem because I put the wrong type of antenna on. If we take this off and have a look at the connections in there, we'll see that there's a hole on both sides. So one of these is supposed to have a pin in it. So what I actually needed was this type of antenna, or this type of connector, which has a pin in the middle so that it's actually going to make a connection there instead of just doing nothing. So now I'm ready to power it up. And is there anything to look at? Actually, oh, we've got lights on the PDB. I didn't know that. Oh, how about that? We've got some little LEDs there. Oh, and this has a LED. Okay, so there is something to look at, but nothing happens on the camera. Anyway, let me just get the goggles ready, and we'll actually see if that is actually sending us some video. Okay, I have my goggles ready now, and the channel that the goggles are listening to is, boy, that's hard to see, isn't it? But in the top left of the screen it says channel R1, so that's race band channel 1, which is not the channel that the transmitter was set to. This one was set to, I think it was band E channel 8. But nevertheless, when we plug it in, we should see a little flicker on the screen, like that. It flickers for a bit and then it goes back to static. But that's a good sign because it means that the receiver is alive and it's doing something on that 5.8 gigahertz frequency range. So now I can use these buttons over here labeled B and CH to change the band and the channel. Well, I think I'll just have to tell you what I'm doing because it's hard to see, but I'm changing it there. And we've got band A, B, C, D, R. So I think the naming that this receiver uses is a bit different, but channel band C is the one that we want. So on the instructions for this it was called band E, and this one there is no E, but I think C is equivalent of E. Anyway, so now let's change the, good lord, it's hard to see. So we got channel 2, 3, 4, 5. You can see that as we get closer we're starting to see less and less static and more of something a little bit useful. So this is channel 7. It's not the channel we want, but we're seeing a usable picture here. But the only reason that we can do this is because the transmitter and the receiver here are so close together that the signal is very, very strong, even if we're not looking at the exact right channel. So if I click up to the next channel, we should see these funny, there's a little bit of funniness in the screen, but if I click to the correct channel, now it looks great. So band C channel 8 is exactly the one that we want. So this is the reason why when you're choosing a channel to fly with, if you're flying with your friends, you want to try and avoid using the channel that's directly next to the channel that your friend is using, because if you can imagine that if you were transmitting on this channel and then your friend was transmitting on channel 7, your friend would see this much of your picture coming in, if you're close together, that is, like if you're flying close to where you're standing, and then he would see some of his view as well, so it would just be terrible. So you want to try and choose a channel that's not too close. Anyway, I think we can see from this that the receiver and the video transmitter and everything are everything's working alright. By the way, it's normal for the video transmitter to get a bit warm, but you don't want to let it get too hot, because normally when it's flying you'd have lots of air going over it and will help it cool down, but when you're just testing it at the bench like this, it's not going to have that much air to cool it down. So yeah, just don't leave it connected up without any proper cooling for a long time. So that's going to do it for this video. I hope everything worked out for you. Thanks for watching. I'll see you next time.